The question is about metal carbonates. A student is given, okay, when heating some metal carbonates decompose, sure. A student is given 3 solid metal carbonates, a timer, some lime water, and this apparatus, okay. Describe the method that student can use to find out which metal carbonate decomposes the fastest when heated, sure. So we know that, what do we have? Well, we have, the information that we have is that it decomposes to form metal oxide and carbon dioxide gas, pretty simple. So we have lime water as well, and we know the test for carbon dioxide is with lime water. So how can we measure which decomposes the fastest? Well, we need to think right away. Oh, lime water is probably the one that's going to help us the most. So what should we do? How do we structure this answer? So it wants a full method, a method. So let's start with what we should do. So the carbonate should be placed in the boiling tube, and lime water in the test tube. Okay, we can see that's what it should be, because the carbon dioxide should be bubbled into the lime water, basically from the boiling tube, the thin tube that connects the two. So it logically makes sense. So next up we see the Bunsen burner. So we need to say what to do with that Bunsen burner. So we need to heat the boiling tube, or heat the carbonate. And how can we measure? Well, we can measure how fast the carbon dioxide is being produced. Well, we can time how long it takes for the lime water to turn, and we know the test for carbon dioxide gas, lime water turns cloudy. How long it takes for the lime water to turn cloudy. Okay. Then we do the finer details of the procedure. So repeat with the same mass of a different carbonate, because we want to control that, and then we're gonna just state something that's gonna help us, like clearly state how we're gonna ascertain our result. So we're gonna say the carbonate which changes the lime water the fastest to cloudy is the one which decomposes the fastest, because that's what we're looking for. We're looking for the metal carbonate which decomposes the fastest. Nice. A student is given a solid metal carbonate with formula XCO3. Sure, X represents a symbol of a group 2 metal. Student uses the apparatus to heat a sample of XCO3 until it decomposes. The equation for the decomposition of XCO3 is XCO3 forms XO plus CO2. Sure. The student records the mass of XCO3 and the mass of carbon dioxide that escapes through the cotton wool plug, and it gives us this results. Okay, it's asking us why the student uses the cotton wool plug. It should be pretty easy to imagine why they use it. It is to prevent the loss of XCO3, right? Because we're reacting it, we don't want it to fly outside of the outside of this test tube, this boiling tube, whatever we're using. So we're going to use a cotton wool plug. Okay, calculate the amount in moles of carbon dioxide produced. Okay, it gives us the MR, and it's going to give us the mass of CO2, 2.2. Mass over molar mass, I'm going to use the formula. So it's going to give us 2.2 divided by 44. And 2.2 divided by 44, it's going to give us an answer of 0.05 moles of carbon dioxide. And then use the equation to determine the amount of moles of XCO3 that decomposed. Well, we can see that the ratio in the equation, it doesn't say that it's balanced, but we're assuming it's balanced here because of the way it's written. It looks balanced. So it's going to look like a 1-to-1-to-1 ratio, right? 1 mole of XCO3 1 part XCO3, 1 to XO, 1 to CO2. And we know the moles of CO2 is 0.05, so by that logic we should know the amount of XCO3 is also 0.05. Now, use the mass of XCO3 and your answer for BII to calculate the relative formula mass of XCO3. Well, we can see our answer for B triple I is 0.05 moles, right? So what are we going to do? Well, we're going to need to get the mass of XCO3, which is 7.4 grams. 7.4 grams. And then we're going to do mass over moles equals molar mass, because remember, if we use our little triangle here that we should be remembering, we see mass is on top, molar mass here, and moles here. So moles times molar mass equals mass, mass over moles equals molar mass, and mass over molar mass equals moles. So if we want the molar mass, we're going to need to do the mass, which is 7.4 grams, divided by the molar mass the moles we calculated, which is 0.05. And thinking of the answer top of my head, should be 148. 148 sounds about right. That should be the formula mass, MR of that. Okay, using your answer to BIV and the periodic table on page 2 to determine the identity of group 2 metal X. So, where it's asking us, okay, sure, group 2 metal X. What's this final marking? Okay, so basically, we don't know what X is, but we know what CO3 is, right? So, by that logic, we know the total molar mass, so we know 148 is the total molar mass, right? And that's equal to the sum of the different elements inside of it. So X plus C plus O3, right? And while we might not know X, we certainly do know C plus O3, right? C should be 12 and O3 should be 16 times 3, right? So what can we do here? Well, we can do 16 times 3, 48, plus 12 is 60. So 148 equals X plus 60. Gives us a nice little equation here, and we solve that X should equal to 88. And now we're looking for in the periodic table we're looking for something that has the molar mass of 82. And you can turn to the periodic table right now, but I will tell you that the metal of the group 2 metal that has molar mass of 88 is strontium. So SR.